In this PowerPoint, we'll cover Chapter 1, the history of engineering. So let's begin with the impact of engineering. The impact of engineers in society is significant. Throughout history, it has proven its significance. Our life expectancy, for example, is so much higher than before because of the technologies that engineers have developed. So examples of these technologies are safe drinking water, sanitation, accessible medicine. So these are all examples of engineering feats. The study of the history of engineering, why we're studying this Chapter 1, is to highlight the diversity and heritage of the engineering profession and also pay tribute to a few of the great engineers who have developed the technology in the world in which we live in today. So, definition of engineering. The organization that accredits the engineering programs is called ABET. And I'm not going to read this out to you. You can read it in the PowerPoint file, but it's good to know. But really, in plain language, the definition of engineering is as follows. You have 3 responsibilities as an engineer, which is to develop judgment so that you can help mankind in economical ways. So you want to develop judgment, help mankind, and also in economical ways, which is really a significant thing. That is when a technology can become adopted. Okay, so it places the obligation on the engineer, on us, to address the needs that benefit others and to make sure that we're not doing harm. We seek to provide economical solutions because if they're too expensive, then they're out of reach of people and that technology will not become used and adopted by the masses. Okay, so why study the history of engineering? Looking at case histories and historical overviews can help us see how others have applied these principles before us, understand more about the profession that we're entering, and give us a sense of belonging to the profession that we're going to be in. Okay, so we have another definition here, and I'll just read some parts of it. This definition is from the National Academy of Engineering. So it talks about how no profession unleashes the spirit of engineering, like innovation like engineering. So I'll read the second paragraph here because I think it's key. From research to real-world applications, engineers are really constantly discovering how to improve our lives by creating bold new solutions that connect science to life in unexpected, forward-thinking ways. Okay, so few professions turn so many ideas into so many realities and have such direct and positive effects on everybody's everyday lives. So let's go all the way back to the beginning of engineering. The foundations of engineering were laid with our ancestors' efforts to improve their quality of life. So just from the very beginning, they looked around their environments and saw areas where life could be made easier and more stable. They found improved ways to provide for food through hunting and fishing. Prehistoric engineers applied problem solving and tool making all the way back then, but of course did not have a grasp of the same mathematical principles or knowledge of natural science as we know today. It's become much more sophisticated and complex, but they still design and build items more by trial and error, testing and intuition. And that's something we still do today. We still do trial and error. We still do testing. We still have intuition. There's also evidence of them using principles of aerodynamics and mechanical advantage to develop more efficient tools to hunt. Okay, so going to transportation. Next, transportation was another area where early engineers had made an impact. So the design of early boats still inspire even today's engineers. Transportation really influences others and brings back knowledge. Transportation was used to hunt and fish, move families, explore new areas. If you look at Polynesian boat designers, they developed crafts that could sail great distances, and their use of mathematics and astronomy allowed them to navigate great distances on their vessels that were designed for long ocean voyages. And these engineering feats are still a marvel today. So we'll also look at early cities. As cities grew and there was a need to address the demands of new societies, a big change took place. People who showed special talent in certain areas were identified and assigned to these specialized tasks. So this gave them time and resources to dedicate themselves to building and innovation. Okay, so it's good that, during this time, because of these cities, people now had specific roles to play the role as an engineer, and they could then focus on that role and then became more efficient as engineers. So this new social function created the first real engineers, and innovation then from then on flourished even more rapidly. So between 4000 and 2000 BC, the following things were happening. Egypt and Africa and in the Middle East were two areas for early engineering activities. Stone tools were developed to help humans in their quest for food. Copper and bronze axes were perfected through smelting. There was hunting, there was agriculture, and the plow was allowing humans to become farmers so they could reside in one place and give up the nomadic life of having to move around and having to forage for food. They can now stay in one place and grow food. Engineering skills that were applied to development of everyday items quickly improved life. So examples are the wheel, the sailing boat, and the methods of writing. We also have, of course, comes to mind the construction of pyramids between 2700 and 2500 BC. These early engineers used simple tools performed with great insight, accuracy, technical vigor, and tasks. Even today we still marvel at their achievements. And of course, the number of engineers required was immense. They had to make sure everything was going to fit perfectly. And now we talk about civil engineering. As civilizations grew around the world, the need for infrastructure, of course, increased. And early civil engineers met this challenge. Cities in many places like India, China, and the Americas. Early engineering achievements can be seen even today in these many places. So the pyramids still stand in Latin America, the skill and expertise of early Native American engineers. So cities were constructed that included sophisticated infrastructure and building techniques. Even by today's standards, architects and engineers still marvel at it. What comes to mind, of course, is the Incan city of Machu Picchu. They used sophisticated techniques of dry stone walls that fuse huge blocks without use of mortar. Just completely impressive. Okay, the design of the city was based on alignments that showed mathematical and astronomical, sophistication, and just the fact that the site at the top of the mountains would have created significant engineering challenges of its own. Even recreating this today would be a really amazing feat of technology and engineering. Okay, so other cities that come to mind that we won't talk too much about in length in this PowerPoint is in Greece, the Parthenian, and the Roman aqueducts and roads, and of course the Great Wall of China. Okay. Next, let's talk about agricultural engineering. The development of agricultural practices included many contributions from engineers. For example, the plow was an example of a mechanism that made it easier and more productive to grow food. The first sustainability engineers were still studying their very sophisticated ways that these indigenous people incorporated an understanding of the land and the environment in their efforts to produce a sustainable processes, something that we could and should really learn from today. Recent discoveries in the Amazon River basin show that native peoples had cultivated much of what is the Amazon jungle today, and it was done in a much more environmentally friendly manner than what is currently being done today. Researchers are studying these ancient methods to inform practices of today to develop a much more sustainable approach for protecting one of the most biodiverse places on the planet. Right, so next let's talk about the industrial age. In the earliest centuries, advances were slow and developed over a long period of time, right? Well, the pace of technological change increased as much more technology was developed. So machines were created and performed tasks much more efficiently than people or animals could. So from relying to horses to locomotives and automobiles, this made a big difference. Ships could also power themselves instead of relying on wind, and rowing, so relied less on the environment and relied less on self-propelling and could now power themselves. So these machines were introduced to provide power and change the way really many industries perform, especially areas like mining and agriculture. So the industrial age really produced machines that could replace the need for manual labor and also created new jobs for people to manufacture, operate, and repair these machines. Okay, so making technology accessible. The invention of machines was significant, but engineers are also interested in how they are used and by whom. The invention of the automobile didn't change the lives of ordinary people until it was made more affordable and therefore more accessible to more people. So here I highlight the importance again of affordability, or making it economical for people to use, therefore it will be adopted. So making a technology affordable and accessible to a broad and diverse section of people is a very important aspect of engineering. Okay, so next let's look at large-scale manufacturing. Large-scale manufacturing created new challenges and areas of engineering related to manufacturing. Understanding how these manufacturing processes and how to make them more efficient and safe for workers and the environment opened the way for modern-day field of industrial engineering. So the pioneers here were Dr. Gilbert and her husband Frank were two of the pioneers, right, in this new field. What they did was they introduced the use of time and motion studies to improve the efficiency of manufacturing processes. Okay, so now let's talk about industrial engineering. Industrial engineers today still work with factories to optimize processes. Modern factories integrate now robotics, automation, and people. So industrial engineers also use these techniques to work to optimize healthcare systems, warehouses, and distribution networks for retail and grocery stores, and also systems to address things like natural disasters. And always comes to mind, especially for me, as a web and graphic designer, is Gutenberg and his printing press. So in 1455, Johannes Gutenberg printed the first book, because the Bible. With the invention of the printing press, humans were able to then use, appreciate, and disseminate information as never before. Now they don't have to be written, they don't have to be scribed. Now they can be printed at much faster speed, and therefore meaning that information can be spread so much faster. This is it sounds like it's not a big deal because we're so used to having books around us, but it is a big deal. This is like the invention of the internet, meaning now information can really travel at a much higher speed than it could before. Okay, so the development of printing came at a time where there was a growing need for ability to spread the information. So this came at just the perfect time, and Gutenberg's printing press ignited the flame of widespread communication. Next, of course, we talk about computers, information, and networking. So the computers allowed engineers to perform these analyses and create models that can test ideas without even having to build an actual device. Before, we have to actually build something to test it. Now you can model things, right? So thousands of ideas can be tested in a very short time to find the optimal concept. As computing devices have become faster and even smaller, applications for smart devices have really is now ubiquitous throughout society. So the computers in today's kitchen appliances, if you think about it, are even more powerful than the computers on the Apollo spacecraft that carried astronauts to the moon and back. So your kitchen truly is space age by that standard. Okay, so think about that. So making computers accessible. When computers were invented, they were large and took up whole rooms. Many of these early users greatly underestimated their potential and looked at computers in a very limited way. Bernard M. Gordon helped to design the first commercial digital computer in the United States. He saw this opportunity to use the computer to acquire and process data from measurement instruments. So he was always constantly looking at how he could improve the human condition using his engineering skills. Grace Hopper did the pioneering work in computer languages that allowed even more people to participate in computing. She created compiling languages that use English rather than machine language. So what this means is that she made computers more accessible to more people. And this is really what created the acceleration in technology today, by making it accessible, making it so that people can adopt usage of it. All right, so one other thing I'd like to talk about in engineering is working in teams. So the way we have learned in history does not recognize the idea of teams and shared recognition. We tend to assign a single name to an invention or an accomplishment. We say, okay, Dr. Gilbert did this, or Einstein did that. But there are many reasons why this has been done. Sometimes it's been done to hide the contributions of others, and these people were often people of color and women who were not socially recognized at the time, so their contribution was kind of hidden behind someone else. So Edison worked with actually teams of people who made many incremental advances that ultimately resulted in a light bulb and many other inventions. Along the way, they all suffered many setbacks, lessons learned, and also shared many discoveries. So it's really his team that shared these, discoveries and celebrations. It's usually not one person that discovered something, usually a team of people that discovered something. All right, so in the next chapter, we're going to look at the following disciplines in more detail: aerospace, agriculture, chemical, civil, computer, electrical, industrial, and mechanical. That's chapter 2. And even more, addition to that previous list that I just read off, many additional engineering specialties have evolved over time. So there's actually now over 30 different fields in engineering, which I'm not going to read out right now.